All right, here's a video with so little content it should be illegal. This is about assignment functions. So we've already done functions at the beginning of the course, and what assignment functions do is they allow us to map variables onto individuals. So if we have pronouns like he is happy, we can give this a little subscript like he3, and then when we have a sentence and we check our variables and we take a look at x1, x2, x3, x4, and so on, we can see who x3 maps to. So if this is John, then we know in our sentence that when we say he is happy, this refers to John if it's subscripted with he3. So this is what assignment functions are. Specifically, I lay out an assignment function as a function g from variables to constants. So it takes a variable x something, x1, and it outputs a constant, which is usually a name, so either a lowercase letter or just a full name like Mary. Okay, so here's an example of how we define it. I'm going to say that g1 is an assignment function, and I've specified three things. I've said that g1 of x1 is John. So in matrix notation, this looks like x1 is pointing to John. That's the first line, which maybe I'll change the colors on these. So this is line 1. We have another case where g1 of x2 goes to Mary. So this says that x2 gets assigned to Mary. And for all n greater or equal to 3, g of xn is equal to Pete. Basically, what this means is that if we have, say, x3, this goes to Pete. If we have x4, this goes to Pete. If we have x5, this goes to Pete. And we have to specify this because, as you remember, if we have a function, everything in its domain, so if there's a million things in here, it has to go to something in its range. So, of course, if we have variables, we have an infinite number of them. We go x1, x2, and this just keeps going on and on and on and on, which means that every single one of those has to be defined, which is why we specify specifically that if we have a number greater or equal to 3 there, they go to P. And the number that we pick is going to depend on how many different, individuals we have. Because we just have John, Mary, Pete, we've assigned 3, 4, 5, and so on to Pete. This is all arbitrary. So it depends on what the context is. It depends how we define the problem. So the question is, why is x1 John? Why is x2 Mary? Why is x3 Pete? And so on. The answer to that is just because that's what we're doing. For this example, that's just how it is. Okay, now an assignment function is all fun and games. It's nice. We have variables, we have constants. So pronouns go to constants, but this works for binding too. For instance, if we were to say some cashier, well, some is just a generic unit, some. It's one thing. If I want to check the truth, well, some thing is going to check all the constants somehow. It's going to check all the names. So that variable needs to run through things. And we're going to use assignment functions for that. But I want to show assignment functions first in a sort of different context and in a very concrete context before we do the abstract stuff with uh, quantifier binding. So I want to talk about replacements because we use replacements a lot. We write this as gd/v, and what this basically means is that no matter what v was before, it's now going to point to d. This is what this means. So it's saying that d is replacing whatever v originally mapped to. So here's the function I had from before, g1. This gives us x1 to John, x2 to Mary, and xn to Pete. And I'm doing this substitution here. I'm saying in this substitution, which I'm putting in square brackets, I am replacing whatever x2 is pointing to with Rufus. So this is shown here. So Rufus is going into that x2 slot. I can make a further modification. I can say, okay, I'm going to have Mary go in that x1 slot. So that is what's happening in this first line. And then I do the thing outside of those brackets next. So then I replace Rufus with whatever, I replace whatever x2 was pointing to with Rufus. So to see this in a sentence, how this works, Two things. First of all, now whenever we have a sentence, we're no longer just using V for situation. Instead, we have something called a model, and we have an assignment function. So a model is like a universe. It's very similar to a situation, and the assignment function basically maps our pronouns and binds our quantifiers if we need it. So if we have a sentence, he is happy, well, the meaning of this is dependent on a model and an assignment function. So when we translate this into our predicate logic, we get this as happy with x3 because we have this 3 index. So happy x3. And then we check our function above and we find, okay, when we have x3, that goes to Pete. So this sentence translates to Pete is happy. But let's say we have a sentence, he is happy, but we have our assignment function with the modification. x3 now points to Sam. So when we evaluate happy of x3, and we now are aware that x3 is pointing to Sam with this assignment replacement, we get Sam is happy. So in the next video, we'll talk about how this works with binding. So for all and for some cases. But this is how we use assignment functions when it comes to pronouns. And in 2 lectures from now, when we do the truth conditions of quantified sentences and we talk about pronoun assignment, we're going to use this information. So if there's any questions, as always, email, discussion board. I'll catch you there.